So good afternoon. Welcome to 6858. So today we have a somewhat unusual format. We have a guest lecture by Nick Mathewson, who's joining us by Zoom. He's actually a former MIT undergrad who did his undergrad in MEng at MIT and actually developed, was one of the original developers of Tor itself and has been involved in developing and operating Tor for the last, I guess, 2 decades now almost.
Almost.
So one really exciting thing, well, Nick has been kind enough to give guest lectures in 6858 for quite a number of years now in the past. Hopefully you guys have watched his previous video. In this session, we'd like to have you guys ask questions to Nick and get his perspective. One cool thing is that he's really involved in almost every aspect of Tor. He knows how it works, and you might get a sense of what it's like to run a real security
more some
system.
than others.
Okay, yeah. So maybe I'll sort of kick off to prime other students to ask questions. So what have you guys seen in terms of Tor usage and use cases with all the recent developments, everyone staying home, etc.?
Wow, not a lot of change, honestly. Most of the impact that we've seen has been in people's charitable giving with the economy crashing. There's a lot less, so we operate as a nonprofit, and people's donations to nonprofits that aren't specifically about curing diseases are way, way down. So that's really been the hardest hit. I haven't seen any major shifts in activity or the kinds of information people are asking for. Though, of course, it being a privacy system, we don't tend to go and keep like close track. Hey, what's everybody doing? What are you looking at? And so on.
Makes sense. Thanks. Yeah. So if anyone wants to jump in, feel free anytime. You can like raise your hand or just jump in or type questions. I'll relay them from the chat to Nick. Any of the students want to ask anything? Oh, Daniel, go ahead.
Yeah, so I guess I had a question about, from your lecture, you mentioned that the directory authorities had different ways of voting on which nodes are misbehaving. Do each of the directory authorities have like different definitions and implementations of what's misbehaving, or are they all the same?
Good question. In practice, there's nothing stopping them from having different implementations and ideas of what counts as misbehaving. In practice, there doesn't seem to be quite enough volunteer resources to do separate investigations on behalf of every directory service. So what there is in practice is a group of volunteers who run various tests on relays on the network looking for patterns of bad behavior. And some of the authorities listen to them.
Thanks.
No problem.
One question I wanted to relay from chat is one of the students asking if you can say more about how hidden servers work and what you guys see maybe as use cases. That's maybe more paraphrasing the question, and sort of exactly to what extent do they hide the server operator or not?
Should I be seeing this chat?
So this one I think was sent to me privately. Zoom has a wild array of settings.
Okay. So how hidden services work is kind of complicated. I don't know if the lecture you showed is one of the ones where I went into that or not. But generally speaking, the service that wants to, the host that wants to offer the hidden service, I'll call them the service, picks a few relays on the network to serve as long-term introduction points to the service. That is, go to this point if you want to get a hold of me. They publish a signed document saying so to various positions in a hash ring. Then later on, if a client wants to talk to them, the client picks another relay on the network to act as a rendezvous point that carries the actual communication. And then the client opens a circuit to the introduction point, gives the introduction point, the client goes to one of the points on the hash ring to get the directory entry. From that, they learn the introduction points. They connect to an introduction point, tell the introduction point about which relay they're using as a rendezvous point. And then the hidden service can open a circuit to the rendezvous point. They can handshake and talk to each other. Use cases that seem to go pretty well. It seems to work really well for chat. It seems to work well for firewall piercing if you want to like have a address for your server that you can SSH it into, for instance, and you don't want to expose your server at all. Or if you want to have like online presence that with mobility that isn't linkable to you, those are some pretty decent things. For publicly available, public-facing stuff, sometimes it gets used for websites and the like. This is more susceptible to denial of service because you have to tell everybody what your address is. As for how private it is, it's a form of responder anonymity. Responder anonymity in the sense that it's not the person starting the conversation who wants the privacy, it's the person who is receiving the response. And it seems that those are, that when you have responder anonymity, you're getting somewhat less privacy than you do from initiator anonymity, simply because other parties besides you get to decide when the communication happens and how much of it happens in a way that isn't under your control. So it's probably a bit more vulnerable to traffic analysis than other forms might be. Though, of course, we try to do what we can to limit that. And that is the quick version. There are a few other tricks as well. That is, the current version of hidden services uses a neat cryptographic trick so that the directory entries, although they are signed with a key that is derived from the identity of the hidden service in a one-way manner, so that the directory services can tell, yes, this is a valid descriptor for someone, but they can't use it to talk to them, and they can't tell who's it's supposed to be for unless they actually know the identity of the hidden service. And that lets you work with a little more privacy and reduce enumeration attacks.
Cool. Robert had a question.
Yeah, I was curious if you would like explain your details, the details of, or sort of your opinion on the thing that happens with Carnegie Mellon, like a couple of years ago. Do you know the thing I'm talking about?
The thing that happened from Carnegie Mellon.
They were like doing research on Tor.
Let me make sure I'm thinking about the right people, because if I start talking about people, let's see. So yeah, they, for anyone who doesn't know, there was a group that was doing a research project that simultaneously, as I understand it, they were selling or promoting to law enforcement as a possible de-anonymization technique, doing wide scattershot attacks against random users on the Tor network with no discrimination based on, are these people doing a crime or not? This is a big part of why, of course, law enforcement was not interested, because you cannot legally just intrude on people's privacy and do what amounts to an illegal wiretap without a warrant on absolutely everybody and hope to ever get a prosecution out of that. They wound up having some difficulty getting their research published when it turned out that the research was, in a way that they did not actually admit in their paper, actually done against a wide body of live users on the network. So that's about what I got on that. They found a bug that allowed a tagging attack between hidden service directories and guards that basically allowed a hidden service directory to tell the guard, the relay that sees which IP address the user is coming from, which hidden service they were downloading information about. This tagging attack opportunity, we closed it as soon as we found out about it, but we didn't find out about it from them. We found out about it through other ways. And we didn't find out from them that they were doing this in the wild. We found out by doing an investigation because we didn't trust them. My understanding is that this is not how CMU says you're supposed to do research. And I would suggest that if anyone is thinking of doing research that involves indiscriminately invading the privacy of a large number of people, they should talk to their advisor first and consider talking to a research ethics board or whoever the relevant authority is. We can certainly help you design experiments that do not indiscriminately invade people's privacy, and we love to do so. And also, we love to find out about bugs and help people and love help fixing them. I see there's a question in the chat about how does a guard node work. Shall I take that one now?
Sure, go ahead.
All right. Question is from Emily Gray. How does a guard node work? It is supposed to increase probability of having no compromised circuits, but how? Where are they located on the circuit, and what makes them different? All right, so I'll sort of walk through the logic here. The original idea of a guard node came out of a paper from UMass that was in response to a system called crowds, and the paper is very old, but it was called by a different name. It was called helper nodes in that. But the idea is basically, so the key idea that I hope I covered in this lecture, one of the things that, since I don't really know which lecture exactly you saw, I don't know exactly what I covered and what I didn't, but I'm going to assume that I covered end-to-end traffic and timing correlation, where if there's an attacker who can see the same traffic at two different points, then unless there's something happening in the middle to substantially change the shape of the traffic and the volume of the traffic, the attacker will be able to correlate those 2 points. Well, if we say that those 2 points are like a website that you're visiting and the first relay on your circuit, then the attacker will be able to say, okay, this client who's connecting to me is going to this website. Well, how can we make this less likely? How should users actually choose their circuits? If users just choose a circuit randomly every time and say 1/10 of the relays, and I'm choosing a fraction at random, are compromised by some attacker, that attacker will be the first node and the last node on 1/100th of their circuits, all other things being equal. Now, that might not seem to be 1/100th, but presumably we believe that statistics works and random sampling works. If that's so, letting an attacker see a random sample of your circuits is about as bad as letting them see most of your circuits. They get a fair idea of what you do online, who you talk to online, and so on. If you're going to use a system like Tor over time for a lot of traffic, having any of your traffic observed is about as bad as having a lot of it observed. So the idea with guard nodes is you pick just to finish up that argument. So although with probability 1 out of 100, any given circuit gets observed with the random selection model, the probability that you get profiled over a long time goes to 1, and that's not good. So the idea with guard nodes is you pick a relay to be your first hop, and you reuse that first hop for a very long time. If you chose a bad one, well, that's probability 1 out of 10. You just got a bad first hop, and too bad for you. But with probability 9 out of 10, you didn't get a bad first hop, and you don't get observed, and you don't get profiled. This is, it's a suboptimal solution. It would be better to have something that actually resisted end-to-end traffic analysis in a practical, deployable way. This remains an open research topic that we're trying to make inroads on here and there. We've started to do some stuff with traffic padding in the last couple of years for limited purposes, but we have a more general model that we hope we can eventually use for better forms of traffic padding. Shall I go down with questions in chat?
Sure, yeah, go ahead.
All right. So attacking attack is basically an attack. So the question is, could you expand on what you mean by attacking attack and how this one worked? Basically, there was a way for an attacker to set a bit to 1 or 0 on a returning message in a way that, on a returning relay cell, in a way that the guard node could observe. This was enough to send basically 1 bit per cell, which is enough with sufficient cells to send an arbitrary message. By tagging, in general, I mean observable malleability in a way that you can use to create a side channel between different relays on the same circuit. There are probably other ways to express that. Next one. It seems that unobservability is not really a focus of Tor. Would it be feasible to have your proxy continually spitting out junk traffic so that when you have a real request, it is hidden? Is there anything like this? Interesting question. So the idea is basically, can you make so the extreme form of this unobservability here in the sense of people can't tell when you're doing activity. With Tor, if someone is watching you, they can tell that you're doing something. They just can't tell what. We hope. So if you had a proxy that was always on and always transmitting traffic at the same volume, then you, in that case, yes, you could in fact hide the fact that you were online from anyone just watching traffic leave your proxy. Now, at some point, the network would have a observable difference with your behavior or not. But it would be much harder to link it to you if no one can tell when you're online. Of course, constantly sending traffic at whatever volume you might ever want to send is usually more than people will want to pay. The number of users who are willing to send that much cover traffic is pretty low. It would certainly not work for mobile users who need the ability to go offline, who need to conserve battery, and so on. So kind of a holy grail there, a really interesting research result, if someone could find it, is something less than constant volume traffic that would still do a good job of concealing when you're online and when you're not. Another wrinkle there is that no one is perfectly online. Even MIT's network has downtime. And if somebody suspects that you may be doing something that they want to observe, they may be able to deliberately shut down your connection in order to observe whether the activity they suspect you of doing turns off or not. I believe that was how they caught one of the people who was involved with the so-called anonymous group back like 10 or 15 years ago or whenever that was. So cover traffic is cool, but it's not a complete solution, and it's a very expensive solution. Another reason it's very expensive is that the number of simultaneous clients that you can support, if every client is always online, then is much lower. And the number of people who are willing to be those clients is much lower. So although you're providing what may be a stronger privacy guarantee, you're providing it to a much lower anonymity set and possibly reaching a much lower fraction of people. Also, ultimately speaking, this is a computer program. People expect to turn those off. People expect to be able to close their browser, to close their laptop, to shut down their desktop, and telling them that they can never do that if they want privacy is not how people currently expect to use computers. And our ability to reprogram users is limited. So Yeah, this is, I don't mean to say this approach is a non-starter. It's just hard and limited. Let's see. How much traffic does a typical OR forward? Would being an operator help cover activity well? That's from Daniel Robert, and your last name is truncated. It can vary. I think the minimum is something like 20 or 40K per second if you want to be on the network and listed. I expect that will become either higher with time if we keep going in the direction we're going, where we need to cover more and more traffic, but we continue to have scaling issues that keep us from going to tens or hundreds of thousands of relays. Or it might go down if we deploy some of the stuff we've been working on the last couple of years with the so-called walking onions design that's meant to help us scale better. I think that having a relay at that you operate and send all of your traffic through could help somewhat, but if it might also raise suspicion on you if all of this stuff gets traced back to the same relay, and it just so happens that you are operating that relay. So there's some gain and some loss. I would suggest not operating a relay out of your dorm room or out of wherever you're staying during quarantine, because unless you are willing to get to bear the possibility of some increased attention for that. On the other hand, some people have reported running relays and exit nodes out of their dorm rooms and nothing bad happening, so perhaps I am more paranoid than the average person. Next, there's one from A. David. Can you talk about how your personal work has evolved over the years? How much time do you spend developing code, doing research, analysis, etc.? It changes a lot. I still get to code, and I still really like coding, but I spend a lot more time on code review, design review, and specification these days than I did before. I like that too. The part I really don't like so much is meetings. If I can spend less than a fifth of my time in meetings, then I think I'm doing great. I don't do as much just pure research as I used to, just because the bar that you need to clear in order to get something published is really different than the bar you need to clear in order to get it practical. And a lot of the work isn't reusable in both cases. Let's see. There's a name that I'm likely to mispronounce, Kritamate, saying, I don't know if I missed this from the paper, but I don't know, like, in terms of incentives, how do you get some PC to operate as ORs? Mostly they're volunteers, people who think that it would be good to provide traffic for the network. Some of them are funded by other nonprofits. We don't do this, but there are some nonprofits in Europe that work as pass-throughs to compensate operators of ORs for their bandwidth costs and hosting costs. They try to arrange things so that they don't have administrative authority over too many relays, and so they aren't funding anybody to be the administrator of too many relays to control too much of the network. There are proposals to try to do different kinds of incentive schemes. One that a lot of people have come up with is, what if we could arrange for relays to receive payments from some users in exchange for the traffic they relay? One that people come up with is, what if running a relay would generate some kind of currency that you could exchange in turn for better traffic performance? One challenge there is that we believe pretty strongly that it's important that you be able to get privacy without paying for it. A lot of our users do not have much money, and so there should be some option to use a network without paying real money for it. Also, it's not really clear what happens if you start getting into a situation where you're paying for better performance. Like, would that create two separate anonymity groups where the people who are paying don't look at all like the people who are paying? There's been some research on that, published in different venues over the years. I think there may be a paper at the forthcoming Privacy Enhancing Technology Symposium that this year is not going to happen in Montreal. I don't know when we're going to have in-person conferences again, but if you're interested in reading more research about this field, a good place to start is PET's Privacy Enhancing Technologies Symposium, looking at their programs over the last few years. They've switched to a open access model, so you can just read all the papers online, and all of the presentations are online too. And it's not just limited to anonymous communication. It also has lots of other neat topics about privacy. Another thing that I'm going to type into chat now, it's not as well maintained as it should be. That's an anonymity bibliography that I help maintain that has lots of papers about anonymous communication and related topics. Its coverage for the early days of the field is a lot better than its coverage for the past 5 or 6 years, but it's still got a lot of good stuff, and it's worth checking out if you'd like to know more. All right, there's a question. There have been some recent critiques of Tor for the amount of malicious traffic that is routed through the network, vulnerability scanning, etc. Is there a way to greatly reduce malicious traffic while maintaining privacy? I've heard proposals. I don't necessarily believe much of any of them. We have been critiqued for the possibility of sending malicious traffic through us from day one. And before us, you know, TLS was critiqued for, well, SSL at the time, for the possibility of hiding malicious traffic. If you make a useful security tool, then a lot of jerks will use it for evil purposes. If, as near as I can tell, the only way to make a tool that does not get used for malicious purposes at all is to make one that's basically useless. There are lots of useless tools that don't see any illegal traffic because they don't see any traffic. But I would say one way to make things not get malicious traffic is to make them horribly insecure. But of course, horribly insecure systems also get used for malicious purposes. So I don't know that there's a great answer there. There have been proposals from time to time, like, well, can you identify some sorts of traffic and block those? Or can you give somebody a list of all of the malicious things and block them? And the answer is, well, any kind of evil that you can programmatically detect, you can shut down. So that would work. But most forms of things you want to, that you would try to programmatically detect, are easy enough to evade, to change your traffic pattern to do whatever malicious thing you want to do while not triggering whatever form of detection is put in place. So to that end, I mean, if we started saying, hey folks, here's a default, here's a default intrusion detection thing that we think you ought to run on your exit nodes, then people would start circumventing that pretty quickly. There have been proposals saying that all traffic should become traceable with appropriate authority. That is, whenever you use the network, you should have to log in on the one hand with your real identity, escrow that, and have a pseudonym associated with everything you do. And then later, if the appropriate authorities, whoever they may be, decide that the activity at a certain time needs to be unmasked, then you should be unmasked. This is, in my opinion, not a very good idea for several reasons. For the same reason, have you studied key escrow or key escrow proposals at all? Or did you look at the
Really
crypto
look
wars at
into
all?
Astro. No, we talked about it in 5 minutes, but not in much detail.
All right. So generally, these proposals fall apart for lots of reasons. One of them is if you are in fact doing, unless you mandate that only systems of this kind could ever exist, it's not clear why anyone would choose to use them. And a system that doesn't have this feature would just be more secure for all of its users. Another thing is that systems of this kind have a much wider attack surface than systems that don't have tracing in them. So you would need to, they would be much harder to build and audit and keep secure. One objection that has seemed kind of fatal to most systems, most proposals of this kind, is that it's not at all clear who the relevant authorities would be. A consortium of world governments, the UN, any single government, local police force, any judge. There are pros and cons for lots of ways you could suggest that something like that work, but you either would wind up saying, for a tracing proposal of that kind, we either set a very low bar or a very high bar, and it's not really clear what bar would be reasonable that anyone would expect. I mean, other ways that have been proposed to resist malicious traffic has been blocking some kinds of traffic entirely, or blocking things by ports. Most exits don't support SMTP for this reason, just largely because the anti-spam people are, or at least were at the time that we were starting Tor, very active, vocal, and more trouble than it was worth to try to reason with. So everybody decided SMTP, most people decided SMTP was just not worth their time to do. If I could pass or repeal a single bill relating to privacy security policy, what would it be and why? I am not a lawyer and I cannot give legal advice, nor am I much of a policy person. Let's see. CFAA is trouble. Many provisions of the DMCA are deeply problematic, but some more recent stuff like Sesta Fosta is also deeply problematic. You know, honestly, I don't know. I would just take the EFF and give them a blank check for their legislative agenda, under the assumption that they seem to have good heads on their shoulders, and I agree with them far more than I disagree. Have there ever been legal actions against ORs? Seems like an interesting legal topic, especially if you're running as an exit node. I am not aware of, all right, so there's two things you might, well, okay, I guess several things you might do. You might claim that an exit node has civil liability for the traffic going through it. You might claim it has criminal liability for the traffic going through it. Or you might claim, hey, you over there, we think that you, although you claim to be an exit node, are in fact the origin of the traffic. I'm not aware of any attempts to apply civil or criminal liability to a relay operator under the theory that they didn't do it, but they transmitted the traffic and therefore ought to be liable. There have been a couple of nuisance suits against the Tor project where people were claiming that anything done with our software must be our fault. I don't think this is substantially, although I can't, speak about specific stuff, my understanding is that this kind of argument has no more legal merit than claiming that Microsoft is liable if you use Microsoft Office to write a ransom note or a death threat. Now, the largest category of legal cases affecting OR operators has been the category where somebody is doing something bad with an exit, and the IP address seems to be the exit's IP, and so the police assume that whoever owns the exit is in fact the origin of the traffic. None of this has been successfully prosecuted anywhere I'm aware of, because being an exit node is pretty strong evidence that you aren't, in fact, sending what you are supposed to set. On the other hand, you know, this has gotten some people having their nodes, their computers seized and only given back to them like a while after. So please see my earlier note about don't run an exit node from your dorm room. In my opinion, I'm not a lawyer and cannot give legal advice. Good one here. What do you see as the biggest threat to or problem in Tor right now? That's a great question. I'm going to say the size and hairiness of our legacy code base. We have, our code isn't terrible for C code, but it is a C project that's like more than 15 years old now, and it's tricky to maintain. People have successfully volunteered and come up to speed on it, but I think our biggest risk is unless we actually move to a better implementation over time, we're going to find ourselves with an unmaintainable code base where it doesn't really matter if people discover solutions to all of our problems, we won't be able to implement them because the legacy C is too hairy. It's not that bad. People should totally feel free to like have a look, volunteer, sign up, write some code, solve a bug or two. And also our entire code base is not in C. But I think over time we have to migrate to something better. Like, I know currently Rust would be my pick, but that's also a big project and will take a lot of work. Let's see, what are your thoughts on the future prospects of Tor are? Where there's government control over key infrastructure. Yeah, so I'm actually, one of the areas where I'm not an expert is our current anti-censorship stuff. And if you wanted to do an extra unit in this class on anti-censorship, next session is presented, I could really recommend you some great anti-censorship people who could do a good lecture. We actually do have a in-house anti-censorship team now, and they're doing good work. I think it's going to continue to be an arms race. I think that the likeliest outcome is that we continue to be able to circumvent everybody's censorship except China, and that we continue to beat China some of the time, but not all of the time. Right now, the Chinese censorship people seem to have the best combination of resources, technical know-how, and moreover, actually caring about the problem. Lots of countries historically have outsourced their censorship to third-party vendors. And as near as I can tell, when you buy your censorship out of house, your vendor will keep you on an upgrade treadmill where they try to do censorship in a way that will be easy to circumvent so that you have to keep paying for upgrades. Can't prove this, but at one point we were censored in a way where we could get around it simply by changing an uppercase string to a lowercase string in one of our certificates. So other than China, it's not terribly sophisticated right now, and doesn't seem to be getting all that much more sophisticated. Okay, Iran has done during the Green Movement was doing some interesting efforts too, but these days China is the main one to beat, and pretty much everybody else we're successfully getting through. Actually, it turns out that the hard part of stuff like of anti-censorship systems is not getting them to work, but actually getting people to know about them, which is a good transition to the next question. How was Tor initially advertised to gain necessary popularity? Cautiously and slowly to crypto hipsters. And honestly, I think that's the most responsible and interesting way you can advertise a new privacy tool. You encourage, you tell a bunch of people who want to be running the latest and coolest cryptos, hey, we built this new thing, We have no idea if it provides any privacy yet. It probably is terrible. It probably has bugs all over, but it's pretty cool. Would you like to try it out? And honestly, the soft sell does a lot of good in terms of getting people to try it out. Of course, it had to be open source, and it helped a great deal that we had byte-level specifications from the beginning and a design paper pretty early on. I'm not saying that you necessarily need a published design paper in order to get a system accepted, but academic attention did help a lot. Whoa, I've caught up with the questions. So I was initially told I would be answering questions for half an hour. I am happy to keep answering them all the way until the 2:30 mark or whenever this class is over, but I'm also okay to let people who are not super interested, like maybe say bye and have the rest knock out. I don't know, how do the instructors want to do it?
I think
I have budgeted my whole time until 2:30 here.
Yeah, we'd love to have your time to the extent that you're willing to tell us more. But yeah, I think for students, if you guys want to leave and have other things, that's certainly fine with us. And if you want, you can watch the rest of this later when we'll post it online. But otherwise, yeah, happy to relay more questions if you guys have them.
Yeah.
One thing I wanted to ask actually myself is, what have you guys been doing or thinking about in terms of lower latency? So things like the Zoom meeting, for example, it seems like you're in a really low latency connection. So either you're not using Tor or there's something cool going on.
I am not using Tor for this connection. We do have, so Mumble over Tor works reasonably well. We are getting somewhat lower latency there. I think the main idea for what you would need to do to get lower latency, it seems to us, is better congestion control. Our current congestion control algorithm is about what you would get if you had a compiler specialist and a security specialist from MIT, neither of whom actually knew how TCP worked, try to invent the simplest possible congestion control algorithm around 2002. That's how we got it. And we've been tweaking it since. And we've been doing better scheduling at relays since. But it's likely that we're going to need better congestion control. Let me look up a link to this cool congestion control write-up that my colleague Mike Perry did, and I'll post that because it is a pretty thorough examination of, let's see, congestion control there. I know another thing that has been proposed sometimes for better latency is using datagram-based unreliable transport instead of using our reliable in-order transport, so that you could afford to drop packets in the middle. That actually has some difficulty because giving every relay in the middle the opportunity to mess around with and reorder packets opens up a whole lot of side channels. It's not entirely clear how you would fix. Let's see. Given your 2004 lab paper was supported by the Naval Research Labs and DARPA, did they have some interest in it? I'm sorry, were you saying something?
And yeah, I just wanted to follow up on your last comment before maybe jumping to the next question. What kind of side channels are you worried about with the congestion control algorithm?
So, sure. So if you're congestion, no, not with congestion control per se, although there are side channels to worry about there. I'm talking about datagram-based transports as opposed to reliable transports. So right now, traffic on Tor circuits is sent end-to-end, and it's never dropped and it's never reordered.
What would be the side channel?
If, for example, the guard had the option to reorder your packets or drop them, they could encode a message by the order in which they sent them or which ones they dropped that the exit would be able to see. And they could say, encode your IP address with this. If you're curious about more, follow that second link that I just posted on the chat. And if you can think of a way to do a datagram design that doesn't have these flaws, then I would be super interested to talk about that sometime. Next question I see is, was there any interest from the Naval Research Lab and or DARPA, given that our research has been funded by that? Not especially. I don't think there is, the original onion routing design was done by a trio of researchers at the Naval Research Lab. Syverson, I want to say Goldwasser, and Reed. Oh man, Syverson was the only one who stayed involved with it, and because of that, they had some fun. Syverson had some funding to get onion routing developed in the early 2000s. There was a internet startup that both Roger Dinkeldine, the other co-founder of Tor, and I were at that was collapsing at the time, and Roger found this neat research project that we could work on. Fortunately, we managed to get the stuff released as open source software so that we could continue working on it after the research grant expired. I don't think that the original, although of course many people have proposed that the existence of a financial connection to the US government for the research suggests that the research must somehow serve surveillance interests or anti-surveillance interests of the US government. I don't think that's so in any direct way. Ask around your professors in who are doing CS stuff at MIT, what fraction of them have some part of their research come through DARPA or through the US government from other ways, and then, you know, try to get a sense of how much of that you think is actually military. I think that's, honestly, it's mainly just basic research stuff. Yeah, some of the stuff coming out of there does have more of a military bent. I think in this case, it was just a matter of there's a full-time employee who's working on this thing and can write grant proposals and is doing it. If you have not already, whenever there's an IAP thing or a grad opportunity or something to actually find out how research funding works in MIT, you should learn about this, especially if you're interested in public policy or in going into research. It is very much about how the sausage gets made, but if you can get somebody to show you what are all of the grant proposals that they submitted in order to get the funding to do that one or two papers or systems that you liked, it'll be interesting. Let's see, what's next? Let's see. When China or Iran upgrades their censorship, how do you go about figuring out what you need to change to get around it? Huge amount of trial and error, or there's some better strategy. Generally speaking, when somebody upgrades their censorship infrastructure, there's a lot of technically sophisticated users there who have a lot of free time all of a sudden because whatever they were doing to get through the firewall doesn't work anymore. And there's smart computer security people and smart networking people in every country on Earth. And generally speaking, pretty soon after effective censorship goes into place somewhere, there's a lot of people who want to help us figure out what's going on and stuff. Have you or any coworkers gotten offers to work as defense contractors? Technically speaking, since we've had DARPA funding, we are a defense subcontractor. Although that's probably not what you mean. You mean like, you know, have we gotten people headhunting our folks in order to like go work for some major defense contractor that specifically does defense stuff? And the answer is not that I'm aware of. There are people who have worked on Tor stuff who have later gone on to work for people who did do military contracting stuff, but I haven't noticed or been told about any recruiting happening while people were actively at Tor. If you want to get a long-term job working in the defense industry, we are not where I would suggest that you start.
All right. Well, it seems like maybe the questions are winding down, so maybe last call for questions, if you will.
This is where I would offer everybody a Tor sticker to put on your surface of choice. I cannot do that over the internet, but we are a nonprofit, and we are trying to get as much of our income as we can through sources not connected to governments and NGOs. The fraction has been growing, although it's been hard during COVID times. If any of you find yourselves suddenly rich and caring about privacy after MIT, why not consider a donation? We are a tax-deductible charity. Also, if you want to program on anything neat, you can get in touch with us via the website, or my email is easy to find. Just send me a note, and you, yes, you, would be more than welcome hacking on our cool project.
All right. Well, seeing no other questions, I guess I'll sort of, on behalf of all of our students, thank you again so much for.
There's one more question.
Oh yeah, sorry, yeah.
Oh, any thoughts on cool encryption algorithms or any other readings to check out? Well, you might or might not enjoy reading our protocol specifications and our current open proposals. If I can find a link on this laptop, I don't really. This laptop is kind of the one that I assume is going to get affected by all of the horrible things on the internet, which is why I'm zooming from here. Okay, yeah, found. This Git repository has all of our protocol specifications. There is a subdirectory in it called proposals that has all of the proposed protocol changes in it. They are cool to check out. Also, here is something that I have been working on that might be fun to check out. Okay, I just need to, no, that's not the URL. This is a technical report that is basically another version of a paper that's forthcoming in Usenix Security 2020, which also probably isn't going to happen in person. But that's a paper about a way that we found to scale the network without actually, and I guess the clients don't need directories anymore. And it has some other neat properties for security and letting us get faster circuit establishment. And I've been working on detailed specifications there that have some interesting crypto stuff to do them there on over here.
Awesome, thank you.
If there were a way to easily look at opportunities to hack on Tor stuff other than sending you an email, glad you asked. We have a horrible old bug tracker that we are hoping to migrate away from, but it does have all of our open tickets on it. It is track.torproject.org for now. We are hoping to be somewhere better. That's our bug tracker, and if you look for tickets with the keywords easy or intro, those are good first things to look at. Another good place to look at is this is on an older version of the website, but I like, why does this, oh, this is the wrong web browser. Okay, okay, this is the right web browser. There are lots of places to start hacking. Where's the web browser with Zoom in it? I'm so sorry about my technical. There. That's a volunteer page that has lists of things you can do to get started. One of the reasons that I recommend either sending me an email or stopping by our development IRC channel. Is that, which I just typed there, is that sometimes the best way to figure out how to get started hacking on something is to talk with the developers, to sort of talk about what you're interested in, what you can already do, what you're interested in learning how to do, and so on, so that you can work together to find out what's a good fit for your abilities and interests. Like, of the tickets that are marked easy or intro on the bug tracker, some of them are way too easy to be interesting, and some of them are only easy if you know exactly how to fix them. So I would suggest actually like talking to developers first. If you wanted to just get started like hacking around on the Tor client source code, there is a subdirectory called the doc hacking when you fetch our source from Git. And that has instructions on how to get set up with a build environment to build Tor, how the source is laid out, and other stuff like that. You can also read our work in progress documentation for all of our files and functions, if I can find it. That's source, found it. You can tell that I don't use my own website as much as I would like. There, that one is a just API references for how Tor works on the inside. But I'd recommend starting out with one of the other things I posted first, and only getting to that if you really want to like pour through the code. And with that, I'm going to say, I guess we're done. Thanks for listening to me, everybody. I hope one of the things I don't like about this format is there's no way to tell whether people think my jokes are funny or not, or to tell whether people are interested or not. So yeah, I hope it was worth your time. Thank you for having me. I hope to do one of these again at a closer distance.
Thank you so much for doing
again,
this.
Yeah, thank you.
Yeah, thank you.
Thank you, Nick. It was
Please
great.
feel free to wake out.
As always.
Please feel free to reach out, any and all of you. We all need more social contact. Bye, all.
All right. Enjoy.
Bye.
See you.
Thank you.
See you.